Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have a few topics, such as taking over Mastodon instances, a bug that was exploited in Pono and Toronto 2022, and more. First off, though, we'll start out with a post on usurping Mastodon instances, which is a normalization-based issue when it comes to slashes, which is kind of hinted at by the odd slash in the title of the article. If you notice that for those that are watching.
I'll be honest, I did not notice that when I first read this one. I just completely ignored that slash and got to social.
The reason that I noticed it was because I was like, is this a typo maybe? Like, it seemed really weird. And then when I got through the issue, it's like, oh, that's what they're doing. Okay, it's like a little Easter egg. So,
Yeah, makes
yeah.
sense in context for sure. It's a nice
Yeah.
little title, actually.
Yeah, I like it. The problem, the problem that the post tries to get at here is pretty simple. And it's basically that they had logic to remove slashes from domain names inside of the activity publishing or activity pub server. Um, with the goal of removing redundant slashes at the end. The problem was the slashes weren't just deleted from the end, they were deleted from anywhere. And as it turns out, this normalization logic is relevant to checking HTTP signatures. Now, before we get into that, I think we should talk a little bit about Mastodon. I haven't really used it. It gained some popularity after all the crazy Twitter stuff. But part of Mastodon's whole appeal is that it's decentralized. So you can run your own server, you can moderate it however you like. You can use your own domain that's also used for accounts on that site. And the link between different servers is done via the ActivityPub service. And then there's also a discovery service called the WebFinger service, which can be used to look up accounts and whatnot. When instances communicate between each other, they send a web signature inside of the HTTP request, which is basically just a custom header, which contains a key ID of the site with the key as a slug, a headers field that contains the request target, host, and date, as well as the signature, which is a base64 encoding of those header values concatenated together and signed with that given key ID. And the keys themselves have an ID, which is used for lookup, an owner, which is the domain, and public key material. So, for instance, if there's a target account on Mastodon Social that's signed up to some server like chatcommunity.io, and you control the domain mastodon.so, and you're in a position to have like the DNS resolve to Mastodon. The Mastodon.wildcard can resolve to Mastodon.social. You can redirect them to your malicious Mastodon.so website, which has its webfinger provide links and keys that have a slash after the .so. And these are validated as legitimate requests because the key is legitimate. It's attached to the mastodon.social with a slash. But later on, when it goes through that targeted instance, that slash gets stripped out, and effectively you can impersonate the original user with the attacker-controlled domain, which can allow all kinds of fun attacks like man-in-the-middling private messages, spoofing accounts to send DMs to people, or publishing public messages, things like that. Now, it's worth noting you would have to get a situation where you can buy a domain and set up a DNS on one that would match the original domain. So in the example case, they had mastodon.so for mastodon.social, though there's some other TLDs that could be vulnerable or could be attacked like this. They list out some, such as .net can be hit with .ne, .com with .co, .dev with .de, etc. Mainly country TLDs, like even .so is for Somalia. So there is that little bit of a caveat where it kind of depends on the target instance's domain and if you can subvert it
Yeah,
with a
although
TLD of your own.
as
But
they kind of call out, like you can target the subdomain. So as an example, they show like if something's running on like Mastodon, the Fediverse.decentralized.ninja. You can target matching the Fediverse.de and that Fediverse.decentralized. Because if you own that, then you add the slash there, slash is going to get stripped, but you would just set it up as like slash centralized.ninja. So like you do have a pretty fair variety when it comes to what you could potentially attack. There are probably some that there just isn't a good alternative TLD, but especially with a lot of these longer like the TLDs, like the Ninja and Social and like all those, like all the bunch of newer ones there, those longer ones, it feels like there's a reasonable chance that you're going to have some overlap with one of the short other country ones or something like that. The country ones can be a challenge because at least some countries only like you do the .co country suffix, which then you wouldn't really be able to use here, but obviously several do allow. And just calling out the ones that could be used in general against netcom, and I guess dev in this case, that also opens a lot. Because, I mean, there's a lot of .net and .com domains out there, and odds are they didn't register everything, or all of the possible kind of overlapping domains.
Especially where they're country codes, yeah. Where, like, keeping that domain may or may not be tricky, where you have to prove, like, some countries you have to prove that you live there and things like that, so...
Although,
it's
with
an
those,
interesting case of abusing the country TLDs.
yeah, with those that do verify, like, usually there are services that you can kind of get around that with by having a third party register. Like, you pay the third party company to register your domain. I think I remember looking at that when I wanted to register a .it domain several years ago, because that requires, or at least at the time, did require a presence in Italy. Um, so a lot of them do have that sort of service. So it's not like you can't register, but there are hoops to get through. I think this is a cool attack, regardless of like that practical aspect. Just the normalization. It is a really simple error to make there, like deleting the slashes, assuming it's always going to be at the end versus doing the delete suffix. Like just a really simple thing, but when it goes to that normalization, all of a sudden it's matching something it really shouldn't. And the post does go into, you kind of talked it through, but it goes into a lot more detail over how the specifics of like taking over an account would work. But they're able to do it just with, like, fundamentally it is that normalization issue.
It's a very creative attack, so I like that part of it. Something else I wanted to call out is towards the end, they talk a little bit about trying to discover if this vulnerability was exploited in the wild, and their ultimate conclusion is that it's really difficult to tell. They said you might be able to try looking for, domains that are registered with those overlapping TLDs and try to guess from that, but some TLDs don't really provide like a database or anything like that, so it might be tricky to look that up. And it's just kind of an interesting thing that we don't get to see in a lot of posts, especially on the bounty episodes, with trying to discover in the wild exploitation, because it's really tricky to tell, on the internet. So I just thought that was kind of a neat part that they went into, and I wanted to call that out.
Yeah, I mean, like you said, they couldn't get too far with that though, so
Yeah. But still, the fact they exported was cool.
I would be curious actually. I'm not sure they really talk about how they found this issue. Um, it feels like the sort of thing that you'd really have to find, like through code review to notice, like, oh, that seems wrong, and now what can I do with that sort of primitive? Like, where's this used and stuff? It does feel like I'd be curious if their actual analysis was code review or if they happen to have some sort of testing that came across this. I don't think they bring up kind of the discovery process here.
That's a good point. It's
Because
hard to. I would say it would have to be code review, like you're saying, or just an insane like mistake that happens with an overlapping TLD being registered. Maybe, I don't know, but I don't
yeah,
think
I
so.
mean, well, even with the overlapping TLD, like you need to match that last bit too. So
Yeah,
like that feels unlikely to me, especially just given the state of fuzzing on the web and like how it would detect that this sort of bug happened. Like we don't really have the tooling on that side. Like it does feel like you kind of have either gone in knowing that, or maybe in testing just noticed the slashes got stripped from somewhere earlier and then testing. Like I guess I could see some test cases that would turn it up, but yeah, my initial feeling would be, actually looking at the code itself to find it.
because the side effects would be difficult to detect.
Yeah, that's why I said, like, the one thing I could imagine is if you were, say, running another instance and you intended to have the slash there, and well, no, I guess you wouldn't see like a bad request. Yeah, would be. I'd be curious, but fortunately, we just don't have that information here.
All right, so getting into a more complex attack chain, we have a post by D3DA Malicious Group on an attack that allowed theft of auth and session tokens from Akamai and F5 customers. Akamai being the web app firewall, and F5 being a traffic management system that we've covered a few times on the show before. And I'll let Z get into it.
Yeah, I mean, F5 has a lot of applications under them, so a lot can go wrong. We tend to just talk about all as like big IP has this vulnerability, whereas big IP is like, I don't know, 10 applications. But ultimately, like F5 itself is also working as a proxy in front of your actual content. Like they've got their own web application firewall in there too. Uh, there are a couple interesting things with this post, and I'm going to be honest, trying to read it, I did struggle a little bit with trying to follow everything. It's a detailed post, but yet I feel like there were some gaps that kind of left me struggling a little bit. The first thing I want to talk about is this does use request smuggling. So this is a request smuggling attack between Akamai and F5, and didn't really require anything else, or for the entire attack chain. Didn't really require any care about what was actually beyond the F5 server. Just between those two, they were able to get the full chain was the request smuggling, and then also the cache poisoning that kind of allowed the further attacks here. The request smuggling is really interesting, and they don't go into a lot of detail with it. They do bring up the it's a CL0 cache smuggling or content length 0, which I'll bring up here. Portswigger has kind of the post on this, and I believe we covered this actually when we covered the browser powered request smuggling research. And this post actually deviates from it a little bit. So I guess if you're using burp to test for this, you might have already come across this sort of thing, but I want to kind of call out how it deviates. With the original like CL0 testing, the idea was that you would sometimes have endpoints that would be reverse proxy to something that wouldn't expect any content body. So it would expect content length to be 0, and it just would have no expectation that somebody would ever send a post request or a get request in the body. It would just expect that, and so it might be set up to basically just ignore it, or as soon as headers end the request, it assumes the request ends, and so the body of the content could be parsed as a brand new request and kind of be smuggled in that way. And I believe they call that out here as kind of what I don't recall exactly where it is on this page that I'm looking at. But still, the basic idea there was this was depending on just that back end ignoring it, which felt at the time when I first read this as a fairly rare situation. Although this attack that I'm going to use here goes on more of a malformed content length, which is actually a behavior I haven't really seen documented anywhere. It is something that the burp, one of the burp apps, they call it here the HTTP Smuggler B app. It provides some of these options here for how it's doing the attack, and one of them that they use here is this name prefix 1, which is a fairly opaque name. Like, you don't necessarily know what it's doing with that. But what it's doing is it is basically doing a malformed content length header. So name prefix 1 specifically is just adding a space before content length. So if a server were to do any sort of like header matching and simply look for the exact string content length to find the right header, it would miss it because it has a space before. But if something else did normalization of all the headers, it would read it. And so rather than being kind of like the standalone attack like most of the browser powered desyncs were, this one you would still kind of have to have the two servers as per like the traditional request smuggling, but instead of having one parse the content length and one parse the transfer encoding header, in this case one would parse out the content length and the other would not see the content length and assume that content length was 0. So it's still like the CL0. But yeah, the malformed content length, I don't know, maybe there was a Portswigger research post on that documents kind of that idea. I'm not sure where that idea actually came from. It is something that's obviously out there and known because the HTTP Smuggler B app is supporting it. But I haven't actually seen it written up anywhere. Like, this is the first time I'm seeing a post talking about that in particular. So I just want to call it out in terms of at least going forward and testing for it. It is just another route to do that two-party request smuggling. So getting into the actual issues here, of course, Akamai, it seems, would basically read that or would pass through that malformed content length. So it'd take the request and it's going, of course, as Akamai does, proxies the request over to wherever. To the actual, in this case, it's going to be F5, but technically there were other things that were vulnerable too. They just happened to notice, I think, 85% of the headers they were seeing in successful responses had artifacts of F5 big IP being used. Therefore, they kind of went on to target that. And so this was effectively against any Akamai Edge customer. They could send one of these requests, which I guess I should also bring up here to show what it looks like. Their example here, just using the post and the content length header, you'll notice the extra space, as I mentioned, content length 35, and then the body of it is just, get robots. And you would expect in response to this one, you're going to get just the normal response to whatever this post is. However, when it kind of forwards through that F5 big IP server, it's going to see this as it gets to that content length. It's like, this isn't a content length. I don't know what this header is, so it does whatever its default behavior is for it. But it doesn't read it as content length and assumes that this part of the request is a brand new request and it's GIF robot. So then when you send another request through, it's going to start with this, and then the next bit of data is going to fill out that and be whatever request. So it's going to get robots. And so basically, no matter what page that person was requesting or even what method they were using, it's just going to look at this and assume they want to get robots and give them that page back. And so with F5 big IP, it would cache the responses from any requests coming through the Akamai Edge network, which gives a cache poisoning attack that did happen to work kind of globally. This wasn't the sort of thing where just my connection and I'd have kind of a local cache for me. This was something where once it cached that page, it would kind of cache it out for everybody on that server level. So they had multiple servers or something. They don't go too much into why it wasn't hitting on every single request. The example they have here, they have the normal response of a 302 and then the couple that actually hit poisoned. That were poisoned, or they have the example of that. So with the global cache poisoning, they could basically take any request that's coming through and get it, or get the wrong request cache or the wrong response cached because they're controlling the top of that request. Get that cached for whatever request. So what they end up going for in their actual attack here is, several financial customers using this. They targeted the SSO page or the SSO portal, and they went for just a sort of, they call it a header injection attack, and it has the same feel as doing not header injection. So this sort of smuggling does give you control of the headers for the next request. So you do have a header injection there. They specifically went for what they refer to it as a host header injection, which usually you'll see this where you can make a direct request and actually control the host header. If you change the host header, sometimes the application will be using that host header in order to determine what page it's currently on, or like its current URL. So a lot of services that don't necessarily know where they're going to be hosted, they can just look at the host header and kind of figure it out from there. But if an attacker controls that, anything that's depending on that URL might then be rewritten to be incorrect. So that's kind of the attack that they talk about going through on this. And although their actual example of it, I'm just looking for the payload here. Basically, instead of, or I was saying I'm looking for, while I actually did have it on screen here, was that they didn't exactly inject the host header, or at least in any example that they show us, they did not inject a host header. What they did inject was this get http://example.com. And you'll notice normally within HTTP, it's just the path, and then if there is a host that matters, it'll be through the host header, whereas here they're actually including it as part of that initial get line. And I thought that was a little bit interesting. It's going to give kind of this, or potentially can give a similar result. This could also just get stripped out. It could be normalized out. What they ended up getting here as they show it is a redirect to whatever that page was, which does feel a little bit of a weird behavior. If the redirect was normal for like the home page and they would usually get that, or what exactly was going on with why it's like if the redirect was normal or if the redirect was because of their inclusion in there. Like I could understand this exact sort of thing if actually no, that wouldn't entirely make sense. That so this is one of those things that I'm a little bit unclear on exactly how it's operating. But this sort of request is common with HTTP procs. If you've ever set like an HTTP proxy in your browser, this is how it passes on what the actual domain to go through is. That's kind of part of that spec, I guess. I don't think it's actually proper like HTTP 1.1. But a lot of proxies, like a reverse proxy, would support this sort of notation. Um, Ultimately, though, they end up with the redirect. They are able to redirect users from whatever the attack or whatever the original request is to wherever they actually want to go, the attacker control page. They're able to get this cache, so they're able to get anybody making requests to the SSO page uh, to basically go to the attacker controlled page, and through that, they start getting authorization headers, dumping credentials, giving them something pretty powerful, especially because this doesn't. It does depend on the end application having an SSO. That's something that's provided through F5 Big IP. Um, or one of their services provides like the identity and access policy stuff. So they're able to leak the authorization headers, which is fairly powerful. Basically, anybody using Akamai plus F5 would, and with the caching, results in several requests coming to the attacker. They ended up using Burp Collaborator just to start collecting some of these responses. They get the authorization header. Even says basic auth, so this might just be like a base 64 case of the actual password. They do include a little bit of the base 64, and I did decide to decode that. And fortunately, I can't tell if it's going to have a plain text password or not just from that. It looks like all you're able to get from this is TechOps, so looks like it's a username. So no real information on password, but given the fact that it's such a short little bit there that would have to contain the password, that feels like this might even be plain text credentials coming through, rather than still using some other sort of which in fairness with basic auth, like sending plain text credentials, it's kind of the same deal where you're sending plain text credentials when you log in on a normal website. You're ideally going over HTTPS, but you send your raw credentials to the server, so fair enough. But therefore, it seems like they're able to dump raw credentials out of this, or potentially if they decode it. Uh, they reported this, they mentioned here 20 plus bounties, and looks like a lot of these are as their example, they show like 3,000, 3,300, and $4,000. So pretty decent bounties off of it. But they decide to take it a little bit further, and they noticed at least one of the things that was vulnerable to this was sending a post request rather than just these get requests that they were generally collecting, especially because that initial injection looks like a get. But they end up getting these post requests, and those posts have, or what they noticed here was accept auth, and of course NTLM is in there. Like this is part of like an Outlook thing, being proxy here, but they have NTLM in there. So basically, they set up a responder service, and eventually got some hits that actually dropped the NTLM hashes. So a bit of an escalation for that particular application. Um, in closing, like it seems like if the payouts are all in kind of this realm, they got a pretty decent collection of bounties, and they do talk a lot about like all these websites being vulnerable to and all these different endpoints they had to test through and work through. I've glossed over all of that information, but they do go into a bit more of that in the post. Seems like they got like a decent bit of bounties here, but they do kind of call out Akamai for not having provided any bounty. And thinking about it myself, like Akamai's issue here, and the core issue that kind of starts it is the fact Akamai didn't normalize the headers before passing them through, just pass them through as it received them, which is a relatively understandable task when it's just acting as the proxy in the middle.
I feel like you want the proxy to be as intuitive as possible, which that makes the most sense. Like that's the behavior you would expect the most.
I think it's fair to expect the proxy to send valid HTTP requests and not sending anything invalid, especially when it comes to the fact that like it's working as or it can work as the like web application firewall in there. And so it should be looking for any sort of like questionable headers. Because usually if you're going to like add a custom header, it's always like X dash whatever is like your custom header and not space something like an actual
Yeah,
malformed header. So I
I guess
think
a
it's very
prefix
fair.
space is pretty like it's a pretty clear cut case where it should be dropped, but yeah, it is kind of a there is no 100% correct answer really, depending on who's interpreting it.
Like I do think it is fair to expect Akamai to normalize the headers before sending it out, because they're kind of in a sense responsible for their headers and what they actually pass over. I get where you're coming from too, and that's why I think at least on some servers they'll just have like configuration options for like how do you treat certain edge cases, like do you only pass through certain headers, which is another thing, like only allow whitelisted headers through so somebody can't provide like their own host header or something, like you can't pass that, or like X forwarded 4 can't be passed through and stuff. There are kind of config options like that to go through a whole whitelist. um but the thing with the request smuggling is it takes two for, or in this sort of request smuggling it takes two parties. It takes the Akamai and it takes the F5 big IP, uh and neither of them is necessarily, Inspector was saying, wrong in what they're doing, but the combination creates the problem. Because Akamai, Inspector said, like, I think it's fair to have a proxy that doesn't do anything and just proxies it and does like some inspection along the way to drop some things. And then on F5 big IP, when they get the space prefix, like the space before content length, it's also fair for them to say this is not the content length header because it doesn't match the content length header. Um, so no party is making like an inexcusable error here, but it's the combination that results in kind of the issue here.
And
Um,
in cases like that, I think the best route to go is getting the individual bounties, but for the different platforms that are vulnerable with their setups, which is what he did. So
yeah, yeah, which is
yeah,
why like those specific setups caught it, and it just seemed like he kind of expected a bit from Akamai and stuff too. And I kind of understand like I could also imagine Akamai giving like a low or something out of this, like give a few $100 because like they didn't normalize it and like could create issues. But I don't even know if Akamai actually has a bounty program either. Uh,
I'm
Offhand, I
thinking
do.
back, and I don't think I've really seen bounty payouts for Akamai issues because we've covered some before, but
Well,
I
we
might be
covered.
misremembering.
So looks like they are on HackerOne. But it looks like they might just be a vulnerability disclosure program and not an actual bounty.
Yeah,
Oh,
there's no like listing
no,
for
sorry.
payouts, right?
Looks like
Or
it's
is there?
Lino that actually has it.
Ah, okay.
Or oh no, I guess I don't want to dig too much in, but it does mention that. Oh, sorry. Please note Akamai operates the bug bounty for Linode, not through Linode. So yeah, it looks like this is more. Mm, I guess it's also mentioning it's an external program. So yeah, we'd have to dig into that a little bit more. Um, Nonetheless, it does seem like I would assume that they're only doing the vulnerability disclosure and not the actual bug bounty on it. So I mean, it is what it is. This is a hard issue to really put the blame on either side. So I do think it was just going through on all the individual bug bounties, even though that is probably annoying on their side. And one thing I just want to call out, in here, in kind of their closing statement, they kind of talk a little bit about the bounties, and they call it how researchers have the opportunity to shop their research to Zero DM or other initial access brokers. And I'm not a fan of Zero DM. Even if you do want to go that route of selling the issues, like just Zero DM doesn't have the greatest reputation, at least in my mind. We've brought that up a couple times before, just not the most trustworthy place to go for. But I don't believe they are an initial access broker, which is generally going to be illegal to provide. As I understand it, an initial access broker is like if you look on some hacking forums, somebody's going to post and they're like, oh, I have access to XYZ's corporate network and selling you the initial access, because they're not going to do anything, but they'll sell you that access so that you can do whatever you want with it. Whereas Zero DM is purely operating, as I understand it, operating on selling knowledge about these vulnerabilities. Because they go through a subscription, like somebody can subscribe to their vulnerability feed and get information about these vulnerabilities. Perhaps they also sell them out, like on an individual level, but initial access is like you already compromised somebody, and that is generally illegal. As in most places, that is going to be illegal to do. Whereas Zero DM is, they're offering the vulnerabilities. What you do with that, they also have limits on who their clients can be and know your customer stuff. But I don't believe they're an initial access broker. Maybe I'm just don't know something or interpreting the term differently. Maybe they mean that as like kind of providing initial access to the vulnerability or something, or to a vulnerability you could use. I can kind of see that, but as I understand it, I don't believe they are an initial access broker. Kind of a small detail here that I just want to kind of call out that as a very quick correction, because uh, exploit brokers, while maybe some moral questions about that, don't tend to be directly illegal, and initial access brokers, as I'm aware, are almost always illegal.
Yeah. And with talking about not getting payouts from Akamai and whatever, like on the one hand it kind of sucks, but on the other, like I said, with this type of issue where it is more pinned on the setup and not a specific vendor, it makes sense to get the bounties from the individual platforms, which they did get a fair amount from, it seems. So
Yeah,
um
unfortunately, we don't
yeah,
get the
I
whole
mean it's
amount out of like how much of the bounties they got if they were all in this 3,000 ish range. Uh, Given the issue, like I'm assuming this could have been like, especially getting credentials out there, like could easily be high or critical, depending on how you want to have the perspective there. But
yeah, and I mean Akamai and F5 are pretty well used throughout the industry. Like there's probably no shortage of targets you could really report this issue on, and maybe not all of them run bug bounty programs, but you can end up getting a fair amount of bounties from it. So uh, it is nice when we see that from time to time, and this is like a prime example of that. So yeah, even though they didn't get paid out by Akamai, I feel like that's fair, given the fact that they were able to get the reports through all the other programs. All right, so we'll jump into our last topic here, which is a post by Quarks Lab, and it's a follow-up to a post they made in March, and it's a series on their pwn-to-own journey with the Netgear RAX30 router. The part one post talked about some vulns in the wide area network interface, including not verifying certificates and command injection in the router's download functionality. This post focuses on the LAN side of it, and was published much later due to some back and forth with the vendor, which is a little bit weird because these issues were pretty simple, but uh, yeah, so three vulnerabilities are detailed here, two of which aren't super interesting. The first of which is a pretty straightforward buffer overflow due to the use of scanf with no bounds checking, and another overflow-esque issue where the file upload functionality would be written inside of the temp directory with no size verification. So by just sending a really large file, larger than the amount of RAM that's available, you can freeze up the router. The more interesting one, though, is detailed towards the end of the post and is a signature bypass issue when validating firmware. So they talk a little bit about the firmware format. I'll bring it up here for those who can see the screen. It has a header that includes the magic, the SHA-256 signature, and some other various things, and it contains the firmware in ITB format, which has the firmware binary and a flattened device tree of devices. The problem is the way the SHA-256 signature scheme is done is really strange. It basically takes a fixed secret string. I'm doing air quotes that you can't see. It takes this fixed secret string embedded in the firmware along with the firmware contents and uses that to create the SHA-256 digest. So there's no real secrecy here. You can very easily forge a digest, and again, it just speaks to that common problem that we seem to talk about a lot, which is that using crypto doesn't inherently make it secure. You kind of do have to use it properly, and they don't. They have a fixed string that is not secret being used as a secret. So yeah,
Yeah, like
really
this
straightforward
is
issue. Not much more to it. Just kind of funny.
yeah, and this is essentially, instead of it actually being a signature, it's an HMAC. It's a keyed hash, which fair enough. And one of the reasons I actually want to cover this on this episode, like on the bounty episode, rather than being a binary, because those other two issues kind of binary level. This one is still kind of binary level. However, this sort of crypto issue with verifying anything, as you said, using crypto doesn't mean they're actually using crypto properly or correctly. And it's very easy to get things wrong or to do something that you think is secure. Oh, I'm using a value that's only in the code. We're compiling it so it's not visible or whatever. Um, it takes some work to get the value out, but it's not a signature. It's not actually doing kind of what they need it to do here in terms of verifying who kind of controls the file through like a public key signature. Um, and so like even on the web, you'll see this sort of thing where a signature value appears to be used and it's actually doing this sort of hashing system. Because this sort of HMAC system is relatively common to just use a hash as an integrity verification rather than kind of doing it properly. So just something to keep an eye out for. Like those crypto blocks that you come across aren't always as secure as you might think. So that's more actually where I want to go with this post and why I kind of want to include it here as an example of that. Although this case is very binary, I assume most people are listening to this episode probably aren't going to be doing a lot of firmware level work, but you'll see this bug on the web and
We've seen it
desktop.
before.
Yeah.
Yeah, and speaking to what you were talking about with not using crypto correctly and it being kind of hard to catch, I think part of that is because part of the whole intent of crypto is obfuscating the data. It hides the problems that you might have with the scheme, because if you just look at the input and the output, you're like, okay, it looks good to me. But if you actually look at how the pipeline is between the input and output, that's where the problems are. So you get some of these types of issues. All right,
Yeah.
so
Go ahead. I was just
yeah, I was just
basically
gonna wrap
agreeing
it
with
up.
you.
Yeah. So yeah, that's all the topics we have for today. So as always, thanks goes out to everyone who listened. Previous episodes can be found on Twitch, YouTube, Spotify, Apple Podcasts, and more links off of Anchor. Discord and Twitter links are down below or in the chat. And speaking of Discord, we are thinking of moving the podcast to a record-only format, which will allow us to do some more editing and whatnot, and just makes it a bit easier on us where we don't have a fixed time schedule. So we are looking for some feedback on that. Please do post that in our Discord. You can just post that in the general chat. Maybe we'll make like a poll or something for that as well. That might make a little bit more sense, make it a bit more easy.
I
But
mean, people can DM us also. I think we both have open DMs.
so I don't, and I
Oh.
can't seem to fix it because I guess I'm just not smart enough in Discord. But I will try to look through my message requests. So yeah, you can also try DMing us.
I think everybody has message requests by default, but it's not preventing them from sending the message. You can turn that off, so you can't even get requests.
Well, I tried turning it off and it didn't seem to work, but that's outside the point.
Yeah.
But yeah, anyway, just let us know in our Discord or in DMs. We are looking for some feedback, especially from the live viewers, before we go ahead and do that. And if we do, that'll probably be in the new year, which we are rapidly approaching. So yeah, once again, thanks goes to everyone who listened, and we'll be back tomorrow for our binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.